Alright, so first thing I want to talk about is we're going to split up these desks. So you got somebody on the left and somebody on the right, okay? Now, for you, that's going to be you on the left and you on the right, okay? Everybody else, let's see. You are going to be right side. Stephen, you're going to be a left side. You're going to be a left side. You're going to be a right side. Okay? Trust me, with what I want you to do is the left side, matter of fact, let me just write it up here. The left side of the desk is going to do tangent of 30, but not in a calculator. Stay with me. I'm going to explain why. I'm going to show you what I'm talking about. The right side is going to do tangent of 60. Now, in saying this, I know you have no clue what I'm talking about, because I'm not asking you to do it with a calculator. You think you do? I want to hear it. What do you think? Anybody? What do you think?
You want to take the sine of 60 divided by the cosine of 60.
Ah! So let me show you a little something here. Hold on. Not my kids, but because that's what's going to show up. This. The unit circle. Remember this?
Oh.
Now, using that, okay, I want to find the tangent of 60, which is what Jeff said. I want to take, if you don't remember, matter of fact, let's go back to SOHCAHTOA days. What was tangent again? Opposite over adjacent. Now, do you remember that cosine is the what values?
X.
X, sine is the
Y.
Y. What was tangent?
Y.
Y for X. Oh! So you're saying, Siersma, that to find the tangent, I can just take the Y value and divide it by the X value. And we've talked last week about how do we divide fractions?
KFC.
KCF. Keep it, change it, flip it. That's how I remember it too, Ethan. Okay? Keep it, change it, flip it. It's my crazy chicken friend. Let's put it that way. Anybody see that? No. Okay, now, again, I want left side, here's 30 degrees right here. You have an X and Y value, divide them. Right side, you have an X and Y right there, divide them. One minute, maybe 2 minutes tops. Try it. Left side of your table is doing 30 degrees, which is what you're
Left
doing.
side's this
No,
side.
I'm going to right side.
Our left or your left?
My left.
Oh my.
So look over, look here, this is a hard, this side, do 30. This side, do 60. Of your table. There's 2 people at your table, most of you. Daisy, you're doing 30. Jessica's doing 60.
I'm doing what? Wait, what am I doing? He has
Wait,
60.
You're on the right side.
He has 60.
We're doing your left.
Look at me, again. This is, you know what, I don't care. One of you do one of you do the other. It's not that hard. Okay? Decide amongst yourself. It's not that hard. No, it's nothing to do with the calculator at all. Use the points up there. I don't want a decimal answer. Use the points up there. Remember to divide fractions. You keep it, change it, flip it. That's all I'm asking you to do. Yes.
You know what you're doing? What kind of points you got? That's why I'm
Again, take the Y value at your point and divide it by the X value at your point.
Yeah, me either.
It will get easier, I promise. Budget. I'm going to give you another hint if you're still stuck. This point value is square root of 3 over 2, 1/2. This point value is 1/2 square root of 3 over 2. And to divide y by x just means take the y value and divide it by the x value.
I think you gotta switch the screen.
Whoops. So again, 30 has this value, 60 has this value. All you need to do is take the y value, divide by the x value. The y value, divided by the x value. That's what I'm asking you to do. I was trying to see if you could do it without me. Okay.
So which one? I messed up.
Another minute, tops.
Oh. Duh. Glad you did it, Sarah. Okay, something like that. Oh. Can we change it for
Okay, now somebody in the table right in back of you or in front of you should have this. Maybe turn to the people in back in front of you and double check what they did. Some of you got it right. I've just walked around and saw some of it. Some of you do have it right.
I'm gonna do it.
Talk some about bumpers.
No, that would be here Friday.
All right, come back to me. Anybody got an answer for some tangent of 30? I know Michael has tangent of 60. Anybody got tangent of 30? Go ahead.
1 over the square root of 3.
Yes, but I got to simplify it further. That is correct because we
Can't have a
can't
square root on the bottom.
have square roots on the bottom.
I
Right?
thought it
Square root
was
of 3 over 2.
No, it's
Closer.
square root of 3 over 3.
Write it down. Write it down. You'll get it. Go ahead.
Square root of 3 over 3.
Is 60.
Oh.
What about 30? Square root of 3 over 3. You're right. Let me show you. Here we go. Because look, I didn't do anything here. I got divided by, and then I do keep KFC, as Ron would say. Keep it, change it, flip it, which gets multiply across. 2 over 2 square roots of 3. It gets you what Jeff said. 1 over the square root of 3. But I can't have that square root of 3 on the bottom. So I got to do square root of 3 over 3. That's the answer. And then tangent, again, keep it, change it, flip it, multiply across, the 2's cancel, square root of 3 over 1 is just square root of 3, which makes sense. Because the higher the point, the bigger the tangent should be. Because it's sine over cosine, right? And if the sine value gets bigger as I raise, well, the tangent value should get bigger too. Now don't freak out too much about that, even though you already did. Let's move on. Now I'm going to set you into, this is easier than left or right, okay? This is going to be 1. This is going to be 2. Devin, you can go with 1. Ron, you can go with 2. This is going to be 3. Mr. Borsman, you can go with 3, okay? All right. Now, what I want you to do is row 1 is going to find tangent, I'm going to put the unit circle back up here in a second, of 120. Row 2 in the middle here is going to do tangent of 210. Row 3 on the end there is going to do tangent of 330. I'm not asking you to do all 3. I'm asking this group of people, make sure you write down tan 120. This group of people is tan 210. That is 330.
Can you go
okay?
with the...
That's why I'm putting it up right now. Just want to make sure you knew what you were doing first. There you go. There's the unit circle again.
Negative square root of 3.
So, again, find the one you need. 120, 210, 330. Your values are right up there. Use it. Remember what we just got done doing, y over x. And I want you to see something happen. Jeff, you already sound like you kind of know what's going on. Check with the person back in front of you. See if you got the same thing, and if not, see if one of you can talk the other one into it. Do we have the values now? Can I go back to the work? All right. Tangent 120. What'd you guys get?
-1 over 2. Oh, the answer?
Negative square root of 3 over 2.
I tried a lot.
Yeah, I'm stuck.
Jeff, balance out, what'd you get?
Negative square root of 3.
Negative square root of 3.
Same.
Okay, so I got
That's
that.
what I just said.
Oh, I didn't hear you, I'm sorry. I thought you said 1/2 too, sorry, my bad. I didn't hear. What about 210, middle group, what'd you guys get?
Square root of 3 over 2. Negative square root of 3 over 3. No, it's over 1. Wait, negative square root of 3 over 3.
Michael, what'd you get?
I did the wrong one.
Okay, go ahead.
Is it negative square root of 3 over 1?
No, Ethan, you were closer, it's just positive.
Oh.
Because it would end up being a negative divided by a negative. And I'm going to talk about that. How about group 3?
We're close.
Say it. Say it again.
Negative square root of 3 over 3.
Now hold on a second. These two values I did first were in the first quadrant. This is in the second quadrant. This is in the third quadrant. And this is in the fourth quadrant, which I did intentionally. What do you notice between those values?
They all have 3.
They'll have a 3 or a square root of 3 or something, right? They are pretty similar. Also, do you notice that these two values are the same, just opposites?
Yeah.
That these two values are the same, just opposites? And, more than that, in quadrant 1 and in quadrant 3, it's positive. But in 2 and 4, it's negative. Why?
Because.
That's how it
I
works.
don't know.
I'm going to show you why.
Because negative times negative is positive.
That's what I was just trying to say.
Positive is
right?
positive.
If I'm in this quadrant, positive divided by positive is positive. If I'm in this quadrant, negative divided by negative is positive. But in these two, there's only one negative, which would make it negative, right? Okay, let's move on. Let's make this even easier. Let's find the same thing as I did up above, but using the special triangles. Write this in here, 30, 60, 90. Do you remember what goes where?
2, 3, 1,
Square root.
Close.
3 goes by
Below 6.
Yes, square root of 3 goes here.
2 on the hypotenuse.
2 on the hypotenuse,
1 on the other.
and 1 on the other side. And now I want each of you, and I think you can do this because we've already talked about this today, to find those two values. Use that, don't use anything else, use that triangle, go tangent of 60. Somebody remind me, what is tangent again?
Opposite over
Opposite over adjacent, okay. So go to 30 and find it, and then separate problem, go to 60 and find it.
So can we?
No, I don't want it as one value. I want it given as a fraction.
Yeah.
Now, this should be super easy because I already gave you the answers up above. But otherwise, from 30, I'm just going to go opposite over adjacent, which is 1 over the square root of 3, and we've already said we can't have that square root of 3 on bottom. So I do this thing to cancel, multiply across square root of 3 over, what's square root of 3 times square root of 3? 3, right? It's square root of 9, which is 3. Right, there's that value. 60, from 60, I go opposite over adjacent, square root of 3 over 1 is just square root of 3, which, duh, because I already said that up here, right? Okay, so this is so much easier if I just use those special triangles. In fact, now we're going to get to what we're actually going to use those special triangles for, today's stuff. Let's draw another triangle. And I want to do the 45, 45, 90. You guys remember the side lengths for that?
No.
1, 1,
Square root of 2.
square root of 2. Okay. All I want you to do is find tangent of 45. What is it?
1.
From either angle, does it matter?
No.
No, I still go 1 over 1, which is 1, right? Why?
Because.
Let's go back to the unit circle. Hold on, one more thing. Let's go back to the unit circle. And at 45 degrees, what do we see about the x and y values at 45 degrees?
They're the same.
They're the same. So square root of 2 over 2 divided by square root of 2 over 2 It's just 1. Matter of fact, let's take that a step further. What would be the tangent of this point?
-1.
-1.
1. -1.
That leads us to what we're doing today. Go to the front page. All right, so first thing I want to talk about is what tangent means. Anybody know the definition of tangent?
In green.
No. Tangent just means touches once. Touches in one spot. And we're going to write this right here. Tangent, underline it. Right over here. Thank you. I don't know how many times I'm going to do that today. On camera. Nice work, seriously.
Hey, you changed the picture.
I did. Touches
Yes.
in 1. I'll get there. Lay it off. It's Monday. Touches in one spot. Okay? That's what tangent means. Now, you don't care about this, but basically it means this. When I have my unit circle, I got a line that literally touches my unit circle in one spot. Okay? Do you need to know that? No, that's why I didn't put it on the notes. So it's probably put it on. Okay. Now, tangent is sine over cosine. We just talked about this on the previous page. It's the y value over the x value of a point on the unit circle. We know that. We already did that. Now, I want you to take a second. We're going to talk about, we have to determine these vertical asymptotes. I'm going to underline that. I'm going to come back to defining that after you take your calculator, which you should have on your desk, and find all those values. Now, first thing you need to do is go to mode and make sure you're in radians. Go to mode on your calculator and make sure that you are in radians, which means it's highlighted in black. Okay. If you are, then you can go right to these and literally type in tangent 0, tangent pi over 2, tangent, etc. Can I show you, Jonas, can I use that real quick, please? How to do tangent of pi over 2, look up.
Yeah.
Okay. I'm going to literally type in tangent, and the parentheses already shows there. Pi is right here, you can't see my finger, right here, where that, right below clear, so I got to go second, and then the button right below clear. Pi shows up, divided by 2. And watch what happens. What does that mean?
Non-existent.
Non-existent. Does not exist. Which means that at tangent of pi over 2, it is no solution. It does not exist at that point. So if you divide it in your calculator and it says quit, error, domain, whatever, that means no solution at that point. You should be able to find the value of one way or another from every one of those points up there. I'll go over it in about 2 minutes. Alright, so I'd like to move on. So if you don't have that, make sure that you do. Double check your work. Make sure you don't have any negatives where it shouldn't be, because you need these points to be exact. Dennis, did you have a question?
I got decimals. A lot.
I think your calculator was in degrees.
I'm not sure. I got it. It's a rating.
Then just trust me and know that it's this. Because I can tell you what you're doing wrong, but I don't want to go back and do it. Now hold on a second. Do you remember graph of sine? Starts at 0, then what? Up, down, down and up. Yeah, that's right. Now, did you see him do that song in the Super Bowl last night? I was singing up, down, down and up in my living room. My kids were jamming. No? Okay. Here's the thing. Now here's the thing. It went up, down, down and up. But what did it go up to? What was the amplitude height for just normal sine and cosine? It was 1, right? Which is kind of where I'm getting these numbers. Except for I know that it's 1 and negative 1 because, remember, square root of 2 over 2 divided by square root of 2 over 2. Now, but I can tell you graph went from 1 to negative 1. These graphs, crazy. Go to your calculator and go to the y equals button. Clear out whatever's there and just do tangent of x and graph it. So again, go to the y equals button, tangent of x, just press graph to the top right. X is the button next to the alpha, the blue one, where it says x. And it looks crazy, doesn't it?
It's like my heartbeat.
That's pretty much exactly what I'm trying to get at, right? Let me show you up here.
There's something like a stone.
Y equals tangent of x, and I go to graph it, and it looks like that.
I know it's different.
Now, what I want to tell you is, this graph, where these vertical lines, they're called vertical asymptotes. They're not actually part of the graph. The graph looks like this, and then it stops, and then it starts again, and then it stops, and then it starts again. So let me show you again. This graph goes here, and then it stops. And then it goes like this, and then it stops. It stops at vertical asymptotes, which, let's come back up here and now define what a vertical asymptote is. Where the graph is undefined. Where it does not exist, if you prefer to say, as a matter of fact, I'll put that in parentheses. D-N-E means does not exist. The graph does not exist at those points. The graph is undefined at those points. We already know those points. It's at 3 pi over 2 and at pi over 2. Now, the whole key to this is being able to find those vertical asymptotes, because then the graph just repeats itself over and over, if you can just find where those are. Okay? You're going to have to trust me and just stay with me today. This is not as easy as sine and cosine. Now, if we're going to just graph tangent, here's what we're always going to do. There's 4 things that I want you to write in the margin over here. The first thing you need to do, and this is no change from sine or cosine, is 2 tick marks on y-axis. So let's go do that right away. We're going to do it as I'm doing it. As I'm writing it. So I need 2 tick marks on the y-axis, and I just want to do it. That's just like when we did our amplitude stuff. Except for there is no amplitude for these graphs, because the amplitude was the highest minus the lowest divided by 2, right? But these tangent graphs keep going in both directions. There is no highest, there is no lowest, it keeps going. Okay? So there's still an A, like we see in the previous, right here written, but there's no amplitude. Alright, then, second step is 2 tick marks
Isn't that 4?
left of y-axis, which means that in the past we haven't put any on that left side. Now we are. Okay? And on the right side, we've always done 4. Today we're going to do 6. And I promise you, if you do every problem like this, they are all the same. 6 tick marks right of y-axis. So, try and keep them relatively close to the same distance here, if you can. And there's only one more rule, which I'm going to get to later, because I'm not going to do it on this one. It's just about how we label. I'll talk about that when we get to our examples down below. But for tangent of x, the first thing, the most important thing on here is to be able to find our vertical asymptotes. First of all, let's go write this in here, because I want to make sure that we see this 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And these are in radians at 0, at pi over 2, at pi, at 3 pi over 2. I'm going to slow down here. And at 2 pi, and I'll let you kind of copy
I
that
have
in.
no idea what that is.
That's the unit circle, you guys. We've done the unit circle. Look at 0, pi over 2, pi, 3 pi over 2, 2 pi. And just the points at those points. That's it.
2 pi. What's that here?
Pi over 2. And then the bottom one is 3 pi over 2. Now, take a deep breath. Okay, let's keep going. Now, how am I going to graph these? Well, there's a couple of things I need to know down here first. If I suppose that y is a times tangent of bx, let's just change that to an x. Okay. And that b is greater than 0, and that theta is in radians. Don't worry about all that stuff. What I need to know is, how do I find my period and how do I find my cycle? The period is pi divided by b. Remember before it was 2 pi over b? Now it's just pi over b. Now here's the thing. I am going to ask you to graph this, but on a test, I won't ask you to graph this. I'm just going to ask you to identify it, and we'll get to that in a little bit. Okay. For the cycle, it is from negative pi over 2b to the letters TO, by the way, pi over 2b. And that, ladies and gentlemen, is the key to everything. Circle. If you can do that, which is not hard, you know what B is, you just plug it in. And once you can do that, this all becomes really easy. Okay? Stay with me. The vertical asymptotes. Those, what does a vertical line look like? No, I just did it. What's a vertical line look like? Yeah, it's just straight up and down, right? Vertical asymptotes are the lines where the graph does not exist. So the vertical asymptotes occur at the end of each cycle. Alright, so I'm going to go back up to our graph here and I'm going to start labeling some things. And I'm going right according to what the unit circle says by pi over 4s. So this is 1 pi over 4. This is 2 pi over 4, which reduces to pi over 2. I will never ask you to label every one of these points again. Just do it on this one so you can see it. Okay? So the next one would be 3 pi over 4. The next one would be 4 pi over 4, which just reduces to pi. Then 5 pi over 4. Then 6 pi over 4, which reduces to 3 pi over 2. I'm just reducing the ones I can reduce. I'm going to go the other direction, the same thing. Negative pi over 4, negative pi over 2. Where does the graph not exist? Look at our points up above. Where does the graph not exist?
3 pi over 2.
At 3 pi over 2.
And 3 pi over 2.
See, it does not exist here, and it does not exist here, right? So let's go right to where pi over 2 is and draw a vertical line. It's a dashed line that is vertical. That's called a vertical asymptote. And I'm going to go to 3 pi over 2 and do the same thing. And the easiest part about this is take a look. This goes from 1, 2, 3, 4 bars. So I got to go the opposite way. 1, 2, 3, 4 bars. And I got another one there. Now I'm just going to use the values that I made you find. Right? What's tangent of 0? 0. So just like sine, all tangent graphs start at 0. Put a dot right there at 0, 0. All tangent graphs. Now I'm going to put a 1 here and a negative 1 here because there's nothing in front of tan, so that means 1. Okay? If there was something in front of tan, then I'd put those two numbers there. 2, 3, whatever it is. Okay? Now, what is tangent of pi over 4? Look at your table up above. 1. So at pi over 4, go up to 1 and put a dot. At tangent of negative pi over 4.
How did you?
From right here. Right here. Tangent of pi over 4 is 1. Negative pi over 4, tangent is negative 1. Right here. Don't connect those yet. We're going to keep going. Tangent of 3 pi over 4. Again, I have that written right here. It's just negative 1. Tangent of pi. Again, I have that written right here. Is 0. tangent of 5 pi over 4 is 1. And I'm going to stop there because what I want for all tangent graphs is 2 cycles. These graphs, please, please don't connect these on a line. They're not lines. If you look back at that graph, I'll show you again. Do you see how they curved? See how this isn't just a straight line. It kind of comes up and then it curves and then it curves up. Okay? And that's what you need to do to get these graphs right. It's not a straight line. It looks like this. Come up, curve to it, curve towards it, go up. Do the same thing on the next one. Come up, curve to it, go up. And that's what the graph of tangent looks like.
Oh my.
It seems like a lot. I promise you after I get through the first 2, you're going to get it. They don't connect. Why don't they connect? Because of the vertical asymptote, right? The graph starts all over. So every cycle, which by the way, the cycle of this is pi divided by b. Pi divided by 1 is just pi. So the distance from this point to this point is pi. The distance from this point to this point is pi. Stay with me. I promise you it's all the same. Let's go down and graph the next problem. Okay. I've got to first do my x and y axis. So I didn't draw them in here for you purposely. Give yourself a little room to the left. Because remember you need 2 tick marks over there. And 6 on the right. And 1 in each direction in the y. Now, let you catch up to me. I put a 1 and -1 there because my a is 1. Right? Even on this one, what's a on this one? -1, so I still have 1 and -1. But it's going to change the outlook of it. Now, you're going to start to see this, I promise. But let's figure out the vertical asymptote. Because again, I said that the key to this is figuring out what the cycle is. So I want to go -pi over 2 times b. What's b?
0,
Here, let me replace this with an x.
1.
Pi. It's the thing that's in front of the x.
Oh.
So b is pi. 2 pi over 2 pi. What happens to these pi's?
4 pi.
No. What happens? What can I do with these? They just cancel. These just cancel. So I get from -1/2 to 1/2. And now when I say all